Okay, so in this case, A and C, what is the difference? The difference that you notice is that in graph A, there are negative values for y as well. Whereas in graph C, you'll notice that there are no negative values for your y. So see, y, the negative values of y are ignored. No points in negative value. No, I mean like there is no coordinates used for y. So which means it is indicating that your graph must be a modulus 1. So now, is there anything different that you need to do? No, you don't have to do different when it comes to finding the equation. So as you did in the above questions A and B, you do the same thing. So which means you just have to find the intercepts. So if you, what intercepts? X intercepts. Okay, so your X intercept is x comma 0. So it's intercepting here. So your X is negative 3. It's intercepting here. So X is 0. And finally it's intercepting here, which is X equals to 2. Right. So which means your equation is Y equals 2. So general equation says that X minus P, X minus Q, and X minus R. What is P, Q, R? So this is P, Q, and R. These are P, Q, and R. So you just have to replace. So like said earlier, in place of P, write a bracket. In place of Q, you are writing a bracket, and in place of R, also a bracket. Then it's ready to fill in. So your P is negative 3. Then your Q is 0, and then your R is 2. So simplified version is X negative will become positive. So X plus 3. Then you have X minus 0 is X. Then X minus 2. So this is your equation. However, since it is indicating that your equation is a modulus equation, the way the graph is, so you just have to put the modulus sign. Now, can you verify? Yes, you can verify. How do you verify? So, you can actually use y-intercept. Because from the graph, you can easily see what is y-intercept. Your y-axis is being intercepted at this point, when your y is 0 and x is also 0. So will it fulfill this equation? Meaning, when I put my x as 0, am I getting my y also 0? So that's how you can check. From the graph, you already know that y-intercept is 0. Right? So you have an equation. Usually, how do you find y-intercept? You find y-intercept by replacing x with 0. Yes or no? So wherever there is x, replace by 0. And then if your answer is still 0, so 0 plus 3 is 3, but times 0 is 0. 0 times any number is also 0, and this is leading you to 0. That means this is how you verify that, oh yes, my equation that I got is absolutely correct. You're verifying because of the y-intercepts. Understood? Any doubt in here? Or you can also ask me, is it necessary that to verify, do you really have to use only y-intercept? No, you don't have to. You can use other options. Like for example, what you can use is, if you look at this graph, if I take out this point, what is this point? You have x as negative 1, and what is your y? 6, positive 6, right? When x is negative 1, your y is 6. So you can use this equation, and then try to verify. So you can either replace x or you replace y, right? But you can replace only one. So it's like when you replace x as negative 1, your answer should be 6. When you replace y as 6, your answer should be negative 1 for x, right? So what I will do is, I'll try to use x, okay? So in place of x, so what you can do is, since we decided that or concluded that this is the equation, I want to check. So according to this pair here, when I replace x as 6, right? In place of x, and not 6, negative 1. So in place of x, when I replace by negative 1, my answer should be what? Positive 6. So is it positive 6? So let's check. So negative 1 plus 3 is positive 2. Then you have negative 1. Then negative 1, negative 2 is negative 3. So when I multiply, 2 times negative 1 is negative 2. Negative 2 times negative 3 is positive 6. And it is still 6. So it's also verified. Understood? Turn off.